And so at long last we arrived to slope-intercept form. We've learned that all we need to graph a line, all we need to graph is a single point, any point, all we need to graph is a single point, any point, and a slope. And that ordered pair, the ordered pair we use, one of the easiest ones to use, the easiest one we can use is the Y-intercept. That ordered pair could very well be the Y-intercept. It could be the X-intercept. It could be anything. But the Y-intercept is very easy to find because all you have to do with the Y-intercept is you let x equal 0 and then you solve. And 0 is a very easy number to plug into things. So this is why we kind of like using the Y-intercept a lot. So I'm going to provide a definition, and this is a definition in that it's defined as a collection of words that mean something specific in math, and you need to know what this is. This is the definition of slope-intercept form. Slope-intercept form, literally, and this is the correct words of the word literally translating slope, and this means y-intercept. And notice how we just said right up above, all we need is a single point and a slope, and that ordered pair, or that single point, could be the y-intercept. So I'm taking slope, and I'm taking y-intercept, and I'm putting together into this form that's going to very easily tell me what both of it is. Slope-intercept form is the form you get for a line, or I should say the form you get for a linear equation when you, meaning you the person, set it equal to y. I'm going to give an example of this, and we'll kind of more clarify this. So one example would be if I have 2x minus y equals 3, and I want to set that equal to y, well, all I have to do is subtract 3 from both sides, and I get 2x minus 3 minus y equals 0, and then add y to both sides, and now I have the y by itself. 2x minus 3 equals y. That is called slope-intercept form because it is set equal to y. The y is by itself. And so the formal definition for slope-intercept form is y is equal to m times x plus b. And we have to kind of continue with this because I don't know what m and b are. I just created those letters. We're going to say where m is the slope, and by m we mean the coefficient of x, and b, well, I should actually more correctly say 0 comma b is the y-intercept. I'm going to zoom out and I'm going to box this whole thing in as the definition for slope-intercept form. This is one of the things that you want to look back and make sure you have absolutely memorized. Slope-intercept form of y equals mx plus b is absolutely kind of essential for this. So here's an example of how this is going to work, and I want you to look at these examples when you start your homework. Do not start your homework without playing off of these. So I've got y is equal to negative 1/2 times x minus 2. And I want to make this clear that this equation means negative 1/2 times x and then plus a negative 2. We're not always going to write it like this, but this is going to tell me what the different parts are. Your first step, step A, actually that's too light. Step A, first step is to find the slope. So if I'm going to find the slope of this, I'm going to look for the coefficient of the x. Well, let's compare it. Y is equal to, sorry, I'm just moving things down a bit. Y is equal to m times x plus b, mx plus b. And if I compare this, this m goes with that number, and this b goes with that number. So if I compare this, I know that the slope here, and I'm going to write this as m equals -1/2. Okay, so I've got the slope. Now let's go back to the steps that I need to do. Step B. We're going to find the y-intercept. From this, my y-intercept would have to be -2. So I could say b equals -2, but it is more correct to kind of say, and I'm going to sort of cross this out here, just a single faint line, it's more correct to say my y-intercept is the point 0, -2, because that's an ordered pair and that's how I graph. So my third step is to actually create a graph and to take this ordered pair, oops, that's a terrible little arrow line, and plot it. So the 0, -2 is going to go on the y-axis right here. And then finally, I'm going to take the slope and I'm going to start putting points down, just like we did before. -1, 2 means down 1, right 2. Down 1, right 2. Or up 1, left 2. So down 1, right 2 puts points here, 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 here. Notice how I'm going all the way to the edge. Don't stop. We need to put as many points as we can, and it doesn't take much to put. Up 1, left 2, down 1, right 2. I'm going to take out the line drawing tool, connect these. You guys are going to use your straight edges or your student IDs, and you're going to graph it. And then I'm going to label this line, y is equal to -1/2 x minus 2. Okay. Finally, after all this, so my C is to plot the y-intercept. My D is to plot many other points and connect. My part E is check. As I look at this, does this point go right there? Yes. And is this slope negative? Is it downhill? Meaning if I was a ball, would I roll downhill, kind of all the way down? Yes, it is. So that works. That's a check. Let's do another example. Number 2. 5x minus 2y is equal to 6. Okay. Do not look at this and tell me that the slope is 5. This is not yet in slope-intercept form. So I had a step A to find the slope. Well, I'm going to go to step 0, which means convert to slope-intercept form. So to do that, I'm going to take this original equation, 5x minus 2y equals 6, and I want to get the y by itself. So I'm going to, let's get this down here, I'm going to subtract 5x from both sides, giving me -2y is equal to, and I'm going to write the -5x first, -5x plus 6. Then I'm going to take my fraction bar and divide by -2, divide by -2, divide by -2. And what I get is that canceling, so I have y equals, I have -5 over 2, which is -5 over -2, which is positive 5 over 2, x. Then 6 over -2 is -3, so minus 3. Now I'm going to go back to my other steps. Step A, find the slope. Slope is right here. It's the coefficient of the x. Positive 5 over 2. Then find the y-intercept. That's right here, and it's negative this time. Actually, it was negative before. Okay, you see you've seen negatives before. So that's b is -2, or sorry, -3. Whoops, I don't want to put b though. I want to put 0, -3. Then I'm not going to put C and D. I'm just going to draw the graph and go ahead and plot these. So I have 0, -3. Then we're going to do the slope. This is up 5, right 2. So 1, 2, 3, 4, 5, then 1, 2, and I'm going to put a point right there. Same thing, up 5, right 2. I'm going to put a point right here. Then we're going to go down 5, left 2, put a point here. And that covers pretty much all the points I have on the graph, so I'm going to connect these, and done. Let's label it. Y is equal to 5 over 2, 5 halves x, minus 3. As a check, I'm crossing at -3, and my slope is a positive slope. So that works. That looks good. Let's try another one. We're going to do x minus 3y equals 4. So if I do x minus 3y equals 4, then I want to subtract x, and I get -3y equals -x plus 4. Divide by -3, and I get y is equal to, and I have x minus 4/3. Well, that's a little tricky, because if I have x minus 4/3, or sorry, this is 1/3 x, my bad, 1/3 x minus 4/3. That one's not so easy. My slope here, if I look at part A, is 1/3. That's okay, but my y-intercept, b, is 0, -4/3. Well, what I don't want you to do is I don't want you necessarily graphing with thirds, because that's just too little. So what we're going to do is a little trick here. We're going to rescale this. How many of you have done that before? I'm going to make it so that all these little tick marks here are actually 1, and this is 2, and this is 3. So we're blowing this up and making the whole thing bigger. And I'm rescaling my x's the same way as I'm rescaling my y's. So if I want to plot 0, -4/3, well, this is 1/3, 2/3, 3/3, 4/3. It goes right here. And I'm going to label these tick marks. This is -1, 1, 2, -2, 1, -1, 2, -2. So I can see how it's been rescaled. So I have -4/3. And then I'm going to go up 1 over 3. Well, since we rescaled the same way, I could do the ratio exactly the same. This is the same as up 1 and over 3, like this. Or I could go up 1 whole unit, which would be to go this way, and then over 3, which would be to go 1, 2, and 3 that way. Doesn't matter. If you look at how the ratio is working, it's all the same. Up 1 over 3, then down 1 left 3. And then I connect. And I'm going to label this line, y is equal to 1/3 x minus 4/3. And then I'm going to check. I have a positive slope of 1/3, and yes, my y-intercept is at -4/3. Okay. As a last point, you guys are going to do a ton of these on your own, but as a last point, I want to talk about two lines. We're going to graph two lines on the same one. I'm going to do 2x plus y is equal to 8, and then I'm going to do 2x plus y is equal to 6. So let's pop over to the left here. If I just subtract 2x, I get y is equal to -2x plus 8. Has a slope of -2. Sorry, m is equal to -2. And that has a y-intercept of 8. So if I plot that, I'm going to need a lot of space here because there's a big y-intercept. So if I plot that, 0, 8 puts me here. And a slope of -2 is down 2, right 1, or up 2, left 1. Put as many points as I can all the way down to the end, so I know because we made this graph big, we've got a lot of points. Shouldn't take you too long to put enough dots down. Then I'm going to connect these. And I'll label that. y is equal to negative 2x plus 8. I'm going to switch back over to this one here, and if I subtract 2x, I get y is equal to negative 2x plus 6. So almost the same thing, but I'm starting at 6 up. Remember, I have a slope of negative 2 and a y-intercept of 6. That's a starting point. So I can go down to write 1 from here and keep putting the points all the way down, again, just like we did before. I'm going to go all the way up and do the same thing. You can notice it's really close to the other line, but it's not quite the same. And if I put a line right here, you can see that these two lines will never cross. They have the same slope. Lines with the same slope, there's a mathematical word for this, lines with the same slope are parallel. They never cross. That's enough for now. Hope that's enough examples, and we'll see you later.